Alrighty, let's go to page 20. All right, everyone's on page 20. Page 20. All right, so we're going to learn the reciprocal function this time. So page 20. Okay, first, this thing, CSC. CSC is short for cosecant. C-O-S-E-C-A-N-T. So CSC is short for cosecant. Cosecant. Cosecant is a reciprocal function of sine. So this means 1 over sine. Okay, cosecant means 1 over sine. Okay, we have 3 reciprocal functions. Okay, I'm saying reciprocal because remember, reciprocal means like flip it over. So this is, you flip over the sine function, you get cosecant function. Next one, SEC. SEC stands for secant. S-E-C-A-N-T. This is 1 over cosine. This is 1 over cosine. So we have one that says cosecant, one says secant. The last one, COT. COT means cotangent. This one's easier to remember because it kind of matches up. Cotangent. That is 1 over tangent. All right, so a lot of people have trouble remembering cosecant and secant because, like if you were going to name these functions, you would probably have a C go with C and S go with S. Unfortunately, that is not the case. So the C goes with S and then S goes with C. So please don't get them confused. It's a common mistake. All right, let's go ahead and use that and help us memorize this. Oh, I'm sorry, one more thing. Cotangent. There's another way to describe cotangent. Yes, but in terms of 2 functions. So cotangent is what function over what function? Remember, it's 1 over tangent. Cosine over sine. Cosine over sine. Because tangent is sine over cosine, right? So then the reciprocal of that is cosine over sine. All right, so let's look at a cotangent of negative 5 pi over 6. Cotangent of negative 5 pi over 6. Maybe we should start with one that's easier. Let's do B. Cosecant of pi over 6. Cosecant of pi over 6. What is cosecant? 1 over what function? Good. 1 over sine. So this is the same thing as saying 1 over sine pi over 6. All right, try to recall without your unit circle. What is sine of pi over 6? Pi over 6 is 30 degrees, but what is sine of 30 degrees? 1/2. Very good. So this is going to be 1 over 1/2. 1 over 1/2. Can you do this in your head? 2. Good. Okay, so cosecant of pi over 6 is actually 2. Okay, let's try another easy one. C. Cosecant of pi over 3. Cosecant of pi over 3. So that is 1 over sine pi over 3. What is sine pi over 3? Square root 3 over 2. So 1 over square root 3 over 2. Now this one, you can't do it in your head, but you're still gonna need to rationalize it. So this becomes 2 over square root 3. We can't leave that square root 3 in the denominator, so what do we do? Multiply by what? Yeah, square root 3. Yeah, denominator, square root 3 over square root 3. So this is 2 root 3 over 3. So strange number. You don't have to memorize any of your cosecant, secant, and cotangent stuff. You should just always do it. But sine, cosine, tangent, you got to memorize that over spring break. Okay? So then when you come back and then I say something like, what is cosine 135? 135 degrees, you would tell me negative square root 2 over 2. Okay, so those 3 functions you got to memorize. Other than that, just calculate. All right, let's do a tricky one. Cotangent. Cotangent is what over what? Cosine over sine. So this is cosine negative 5 pi over 6 over sine negative 5 pi over 6. Okay, what is cosine of negative 5 pi over 6? If you cannot remember that, look at your unit circle. So first, it's a negative angle, so we got to go clockwise. Okay, so think about it. Where is negative 5 pi over 6? And what is the cosine of that?
What was the trick that you told us about 2 pi?
You add 2 pi to that if you want it to get into a positive angle. Or what I do is just imagine in my mind where that angle is. Yeah? Not radical 2 over 2. All the radical 2 over 2s are 45 degrees, so it has to be under denominator of 4.
Oh, you mean, sorry.
Yeah.
It's 7 pi over 6.
It is 7 pi over 6. So what is cosine of 7 pi over 6? Think in your mind. 7 pi over 6. Square root 3 over 2. However, we're on the 3rd quadrant now, so negative. Okay, what is the sine of this angle? One over 2, but we're negative. All right. Okay, so this is going to be negative square root 3 over 2 times negative 2. So that's going to cancel, and the negative cancels, square root 3. Okay. All right, let's have you guys try the last 3. But before that, let's have you try D. Make sure that you can get it right first before you try the other 2. Okay, so do D. When you're done, raise your hand. I will check it. Negative 5 pi over 4 is going to be here because you're going to go this way up to 5 pi over 4. So that's actually going to be 3 pi over 4. So this is going to be negative 1. Okay, if you're not sure, then take out your unit circle and look at it for now until you're really familiar with it and you can memorize it. Okay, so everyone please go on to E and F. E and F. When you're done, let me know. Okay, secant of 3 pi is 1 over cosine of 3 pi. If you're not sure where 3 pi is, you start at 0. Goes pi, 2 pi, 3 pi. So 3 pi is the same thing as pi. So that is going to be negative 1. Secant 90 is 1 over cosine 90 degrees. Cosine 90 degrees is here. That is 0. So 1 over 0 is undefined. All right, the next thing is calculator exercise. You got to take out your calculator. I'm going to show you how to use your calculator and common errors. All right, let's do this one. Secant 2. Let's look at your calculator. And I found a calculator here. I don't know whose it is. Oh. All right, first, when you look at your calculator, please find out from your calculator whether you're in degrees or radian. Do you know how to do that? Okay, so looking at this display, you should be able to tell whether you're in degrees or radian. If you cannot, please ask your partner or ask me, but there is a way, it says on there DEG or RAD, that tells you if you're in degrees or radian. And then find the button that switches between degrees and radian. You gotta be able to do that. Okay? Okay, so next, let's look at this one. This says, figure out what secant 2 is. First of all, on your calculator, can you find a secant button? SEC. No, there is no secant button. Therefore, we have to change it into one of the trigonometric functions, which is, your calculator only has 3 trigonometric functions, right? Sine, cosine, tangent. So we got to change it into one of those. So secant is the same as what? 1 over cosine. So this is 1 over cosine 2. 2 what? 2 degrees or 2 radian? Because the answer is very different. 2 radian. If it doesn't have a little degree sign, it is radian. Okay, so this is an important part. This is in radian. Okay, to figure out the actual number, you have to change your calculator into radian. Common mistake, people don't change their calculator mode at all. And so they keep getting the wrong answer and they have no idea what the answer should be. So then they just take whatever answer they get. Don't do that. This is in radian. Make sure you change your calculator into radian mode. If you don't know how to do it, raise your hand. I'll help you. Okay. So first, put in cosine 2. So cosine 2 radian, whatever that number is, take 1 and divide it by that. And then your answer should be negative 2.40. Good? Okay. Cotangent tan. Is this 10 radian or 10 degrees? 10 radian. Is there a cotangent button on your calculator? No. What should you do? Yes, you can do cosine 10 over sine 10, but that is not the fastest way. 1 over tangent is the fastest way. Because you do have a tangent button on the calculator. Okay, so 1 over tangent 10 radian. Okay, what you guys get? 1.554. Okay, about 54. All right, let's do 2 more, and then we are going to move on to graphing. Okay, cotangent pi. What is this? Radian or degrees? Radian, yes. Anytime you see a pi, that's going to be in pi radian. Okay? We did skip C. So I want to finish this one and then go to E. Go back to degrees. Okay, so this is 1 over tangent pi. Try on your calculator.
It says it's an air.
Yeah, it says it's air. What does air mean? Undefined. So I want you guys to know what it means when you see an air on your calculator. It just means undefined. Or maybe you typed something wrong, but this one is undefined. Last one, secant 15 degrees. Secant 15 degrees. First of all, there is no secant button, so what should you do? 1 over cosine, good. 1 over cosine 15 degrees. Now you have to change it back into degrees. Make sure you change it back into degrees. What's the answer of secant 15 degrees? 1.04, very good. All right, last thing, let's graph. Okay, secant, everyone's like, no, don't make us graph. All right, so let's graph cosecant. Cosecant is the same as what? 1 over sine. All right. What is going to make this function undefined? When what happens? Yes, when it's pi, but when what function does what? Yeah, sorry. My question was really weird. Thank you, Kayla, for understanding. When sine is 0, this is going to be undefined, right? So this cannot be 0. So what we're going to do, same thing as when we graph tangent, we are going to graph a sine function to figure out when it's going to be 0 so that we can have some asymptotes. This time we do care about the sine function, so we got to leave that sine function in there so that we can actually graph it correctly. Okay, so let's graph a normal sine. So that's 2 pi here. Pi is halfway, half of that, and then let's go to the left as well. Negative 2 pi, negative pi, and 2 more. Okay, so we're going to graph a normal sine. So it goes, start at 0, goes up 1, and down, down, up. And then same thing on the left. Okay, this is a normal sine graph, correct? Yes?
Did you use 1 as the, or just
Y as 1? Yes. Yeah, so the amplitude does matter in this case. So it has an amplitude of 1, so we're going to draw an amplitude of 1 for sine graph. Okay, what's going to happen when sine approaches 0 or at 0? What happens to my graph? So, yeah, so when sine is 0, the whole thing is undefined, right? So then on my graph, I should see what when these are zeros? Asymptotes. So at these zeros, I'm going to see asymptotes. Okay, the last part is actually the easy part. What you're going to do is you're going to draw some u's. The u's go on top of the sine graph and on the bottom of the sine graph. So basically, it's going to connect to the maximum and the minimum of these sine graphs. Okay, so it's going to look like that, look like this, and look like this. The red parts are the cosecant graph. The blue is not necessary. Like you don't even need it, but you do want it to connect. That's why you leave it in there so that it's easier to graph.
So you draw the u's on the x-axis?
You draw the u's on top of the sine graph. So let me show you on decimals. All right, 2 secant 2x. 2 secant 2x. So what are we going to do first? How do we change this function? One over cosine. So we are going to graph 1 over cosine 2x. The 2's in the front, but I am also going to draw it with an amplitude of 2, just so that it's easier for me to draw my secant. So cosine 2x. Cosine 2x has a period of what? Pi, good. All right, and then when I draw my cosine graph, I'm going to keep it with an amplitude of 2. And then my cosine graph starts on the top, and it goes down, down, up, up. All right, what's the next thing? What should I draw next? Good, asymptotes. I'm going to draw some asymptotes. And the last thing is what? Draw the u's, very good. So u's goes on top and bottom. Okay, so the cosecant graph and the secant graph is pretty much the same. You draw a sine graph or a cosine graph, And then you are basically drawing the cosecant and secant on top of that. Okay, we're going to skip 3 for now because it's kind of the same thing except you're going to move down 3. Let's go to the cotangent graph. Oh, sorry. Did you guys finish copying? Not yet. So when we come back after spring break, we will do some more review before you take the test because you probably will forget most of it over spring break. All right, we're going to draw our last one, which is cotangent. Cotangent theta over 4. All right, we're going to draw cotangent the same way we do tangent. So cotangent is what function over what function? Cosine over sine. So this is cosine theta over 4 over sine theta over 4. What's going to create a problem? Which function is going to create some problems? Sine. So we're going to graph sine first. Sine theta over 4 means the period is what? 2 pi over 1/4. 8 pi. Okay, so 8 pi. Half of that again. We're drawing our sine. This is the amplitude of 1. I'm going to draw some on the left as well. All right, what's the next thing we need to do? Yes, good, asymptotes. All right, the cotangent is a little tricky. We're still going to pick our starting point in the middle. Yeah.
Like on the graph, the x-side, is it 6 or 4?
4, sorry. Yeah. Okay, so the cotangent graph is a little different because we still want to graph the halfway point up to amplitude, except cotangent is going to go down. It's decreasing all the time. Tangent is always increasing. Cotangent is always decreasing. So this is different from the tangent graph. Okay, tangent graph, remember your graph goes up. Cotangent goes down to the right. All right.